Hello, all my 6th grade scientists. Welcome back. All right, so today what we're going to do is we're going to delve in a little deeper to the properties of matter. So we need to think back last week. The properties of matter we were talking about were mass, weight, volume, and density. So we're going to delve in today to mass and weight. And I've got an overall question that I want to kind of focus on. Why are mass and weight so easily confused? Well, let's go back to matter. Matter is anything that has mass and volume. But if it has mass and it's on a place like Earth with gravitational pull, it also has weight. All matter has mass, and so there's going to be gravitational pull on on that matter, and so that will cause weight. All right, so when there's something that has lots of mass, it has lots of gravitational pull, and so it is a heavy object. It will weigh more. If it has less mass, it has less gravitational pull, and it will have less weight. So all those things are interrelated. So since mass and weight are interrelated, maybe that's part of the reason why people get them easily confused. All right, so let's talk more about and compare mass and weight. So first of all, we have mass that measures the amount of matter. So the amount of matter that is contained in something. We talked about that last week. Weight is the measure of the force of gravity on an object. All right, so we've already determined that the more mass something has, the more gravitational pull, so the more weight it would have. So these are interrelated. Now we go to the unit of measure for mass. The unit of measure for mass is grams, kilograms, ounces, and pounds. All right, so the weight, when you measure weight, we measure weight in newtons. So what tools do we use in order to measure these? So with mass, we measure with like a triple beam balance, like we did with the Coke cans on Friday. And then weight would be measured with a spring scale. Okay, so there, that's different again. So mass, one thing that we need to remember about mass is mass never changes. So remember I talked about if we go to another planet, like say Jupiter, more gravitational force, my mass still stays the same. If I go to the moon, less gravitational force, but my mass stays the same. So with weight, it does change with location. So when I go to Jupiter, I weigh more. If I go to the moon, I weigh less. So one thing that I do need to keep in mind, and I've got my daughter's slime to demonstrate this. So mass never changes. So this slime right now has mass, and no matter where I go with this slime in the universe, the mass of this will always stay the same. Now, the only way I can change the mass of something is to take something away or add something to it. So if I take this slime and I decide I don't want that piece, then I have changed the mass of this slime only because I've taken something away from it. If I want to change the mass of this slime again, I can add this back in and I get the original mass because I've used up all the slime and put it back where it was. So that's the only way that I can change the mass of something. All right, so let's go back to our original question. So our original question is, why are mass and weight easily confused? Well, I know when I go into the bathroom and I step up on the scale and I take my weight, I don't get my measurement in newtons. I get my measurement in ounces and pounds, which is like measuring mass. So I think because they are so interrelated and because the scale tells me the measurement for mass, people get those confused. And so that's my theory on why mass and weight are so easily confused, because they are so interchangeable that sometimes we get them confused because of the measurement on the bathroom scale. So what I want you to do is I want you to watch the videos that I have on my link and come back tomorrow, keep watching, and keep learning.